I was talking to a consultant in DC the other day, one of those guys who spends his entire life just buried in regulatory filings.
Right.
And he was oddly upbeat, I mean, almost giddy, as he showed me this new update from the EPA. He points to a section of a cost-benefit analysis, and he just whispers, "Look at that, they finally did it."
And what was it?
In the column where the government usually puts a dollar value on lives saved from clean air, the number was exactly $0 and 0 cents.
Oh.
And he wasn't horrified. He was relieved. To him, this wasn't about people. It was about, and this is his phrase, removing the friction for industry. He kept saying the old way of valuing life was stifling growth, and now the spreadsheets could finally reflect reality.
The spreadsheet reality.
Exactly. And he was so focused on these numbers that he barely blinked when a news alert flashed on his phone about the Thwaites Glacier in the Antarctic.
The Doomsday Glacier.
The one. Scientists had just confirmed it had reached a point of self-sustained collapse. The ice was literally unzipping itself from the seafloor. He just swiped the notification away, said, "The market will adapt."
The market will adapt? Of course it will.
And then he turns his attention right back to a video of a massive new AI data center. He was talking about them with this religious fervor, the engine of the new world, even though their hunger for power had just pushed U.S. coal emissions up for the first time in years.
Which is the great irony of the current AI boom.
So I asked him a simple question. I said, where do you think the power for those servers comes from when the grid hits its limit this summer? And suddenly the whole smugness just evaporated. He got defensive, angry almost, started complaining about bureaucratic red tape, stalling new offshore wind projects, ranting about how we were strangling our own future with regulations, even as he was celebrating the deregulation that was making the planet uninhabitable.
That cognitive dissonance is just staggering.
And that jarring flip, from celebrating the efficiency of a $0 life to panicking about the consequences of his own logic. That feels like the defining spirit of 2026. We've entered a year where the future isn't a distant warning anymore. It's a series of deliberate, documented choices.
And it raises a question that most of us are too afraid to answer.
Have we become so obsessed with the cost of progress that we've forgotten the value of surviving it?
That vignette is chilling, mostly because it highlights this complete epistemological fracture.
Yeah.
You have a class of decision makers operating entirely in a financial abstraction. The spreadsheet, while the physical world, the cryosphere, the actual thermodynamics of the planet, is operating on a completely different timeline.
And the consultant is betting that the spreadsheet can somehow override physics?
Yes, and it's a terrible bet.
And that bet is looking increasingly bad. But the reason we're doing this deep dive today, and the reason we have this massive stack of documents in front of us, Trivium China reports, NDRC guidelines, academic papers on bureaucratic evaluation, energy sector analytics, is to look at the other side of that bet.
Exactly.
Because while Washington is paralyzed by this cost-benefit analysis of whether survival is efficient, there is a massive architectural project happening in the East that has already decided survival is an engineering problem to be solved.
And that's what we're calling the 2026 shift. The mission here is really to strip away all the political rhetoric and just look at the machinery. We need to understand how AI, energy policy, and frankly, political survival mechanisms are being welded together into a single system designed to withstand the very collapse that the consultants swiped away.
Okay, so let's get right into the first pillar of this system. We need to talk about the machine itself. I want to start with a narrative I found in the research that really grounds this whole abstract concept. It's about a woman named Chen Wei.
The systems architect in Ningxia, a perfect place to start.
Right, so I want you to visualize the setting. It's early 2026. The news about Thwaites is breaking everywhere. People are panicking, markets are jittery. But Chen Wei is working in Ningxia province in the arid northwest of China. It's a harsh, landscape, dusty, sun-baked.
Not exactly a global media hub.
And she isn't watching the news about the ice. She's staring at a wall of monitors that are displaying what's called a digital twin of the desert.
And let's just pause on that term digital twin, because it's not just a buzzword. In industrial engineering, this isn't some 3D map or a simulation you run once. A digital twin is a dynamic, real-time virtual replica of a physical system.
So it's alive, in a way.
It's fed by thousands, sometimes millions, of sensors. If the temperature on a single solar panel out in the real desert goes up by 1 degree, the digital twin updates instantly. It allows you to run scenarios and control the physical asset remotely with absolute precision.
So Chen is looking at this digital twin of a massive renewable energy base. And we are talking about thousands upon thousands of solar panels. But they aren't static. in the simulation, and therefore, in reality, they are tilting. They're moving in this perfect AI-optimized synchronization with the sun.
It's almost organic, like sunflowers tracking the light.
It looks exactly like that. And the critical part of the story is where that power goes. It's not just being dumped into a generic grid. It is feeding a massive data center located right there in the middle of the desert.
This is the East Data, West Computing strategy in action, moving the compute to where the energy is cheap and abundant instead of the other way around.
And here's the feedback loop. That data center is running the AI models that calculate the most efficient routing for the entire national power grid. The solar powers the AI, and the AI optimizes the solar.
It's a virtuous cycle.
So while we in the West are reading these headlines about how AI is driving a carbon spike and forcing utilities to revive old coal plants, Chen's reality is totally different. She is operating a system where the growth of intelligence and the preservation of the environment are functionally integrated.
And this is what we're calling functionalist decoupling. It's a dense term, I know, but it is absolutely vital. In the West, we often view environmentalism and industrial growth as a zero-sum game.
Either you save the planet and crush the economy, or you grow the economy and cook the planet.
That's the narrative. Functionalist decoupling argues that through sufficiently advanced macro planning and technology, you can decouple economic growth from carbon emissions. You can have both. Chen Wei's work illustrates that AI isn't the villain of the climate story. In this specific architectural setup, it is the manager of the solution.
Okay, but let's be skeptical for a second. AI plus energy sounds like the kind of buzzword soup you hear at tech conferences in Silicon Valley to get venture capital funding. Is there actual substance to this, or is this just a cool-looking pilot project out in the desert?
It's much, much more than a pilot. We have a deep dive report here from Trivium China, dated late 2025, that dissects the AI plus energy implementation guidelines. These were issued jointly by the National Development and Reform Commission, the NDRC, and the National Energy Administration.
So the macro planner and the energy regulator.
The two most powerful bodies in this space. And these aren't suggestions or white papers. They are industrial policy blueprints. They are marching orders.
So what is the actual problem they're trying to solve? I mean, why do you need AI to run a power grid? We've run power grids for 100 years without it.
We ran simple power grids. To understand this, you have to get into the physics of the grid itself. The old grid was built on a concept called inertia.
Inertia, like in physics class.
Exactly like that. You had massive coal turbines and hydro turbines, these giant, heavy hunks of metal spinning at a very specific frequency. If demand suddenly spiked, the sheer physical momentum of that spinning metal kept the grid stable for the few seconds it took to literally shovel more coal into the furnace. It was heavy, it was stable, and it was, well, dumb.
You burn a rock, a turbine spins, the lights stay on. Simple.
But now look what China's doing. They are aggressively, almost violently, shifting to wind and solar. Solar panels have no moving parts. They have zero inertia. They are inverter-based.
And the wind?
The wind is intermittent. The wind doesn't care if everyone in Shanghai turns on their air conditioner at 6 p.m. on a hot July day. It blows when it blows. If you try to run a massive industrial economy on intermittent renewables that have no inertia, the grid becomes incredibly fragile. It becomes chaotic.
So the complexity just explodes. It exceeds a human's ability to manage it. A guy sitting in a control room pulling levers can't react fast enough to a cloud passing over a solar farm the size of a city.
He can't even see it happening until it's too late. That is the core problem. The AI plus energy plan is about inserting artificial intelligence into every single layer of the system to manage that complexity. It's using AI for, first, demand forecasting and dispatching.
So predicting the future.
In a way, yes. The AI that Chen Wei is monitoring predicts, okay, a weather front is hitting the Gobi solar base in exactly 12 minutes. Generation will drop by 40%. So I need to instantly signal the 3 gorgeous hydro storage to release a precise amount of water to balance the frequency. It all happens in milliseconds.
It's the central nervous system for the entire energy grid.
A perfect analogy. And it goes much deeper than just the big power plants. The report details the planned creation of virtual power plants, or VPPs.
Okay, I keep seeing this acronym everywhere, VPP. It sounds so virtual, like it exists in the cloud, but it has real-world effects.
Break this down for us. What is a virtual power plant?
Imagine you're a grid operator in a major city. You see on your screen that demand is about to outstrip supply. You need 500 megawatts of power right now to prevent a blackout. In the old days, you'd fire up what's called a peaker plant, usually a really dirty, inefficient gas or coal plant that just sits idle waiting for these moments.
Okay, the emergency backup, right. With a VPP, you don't build a new plant. You use software and AI platform to aggregate thousands of small, distributed energy resources.
What kind of resources are we talking about? Like my toaster?
Almost.
Yeah.
We're talking about rooftop solar panels on residential homes. We're talking about home battery walls, like a Tesla power wall.
Yeah.
We're talking about the HVAC systems in large commercial buildings. And the biggest one, the real game changer, is electric vehicles.
So the VPP software connects to all of them?
It connects to all of them. And it can send a signal saying, I need a little bit from everyone. It can tell 5,000 home batteries to discharge 5 kilowatts each simultaneously. Or it can tell 10,000 air conditioners in office buildings to throttle down their compressors by just 10% for 15 minutes. You wouldn't even notice the temperature change.
But to the grid operator, it looks like a single 500 megawatt power plant just magically turned on. But physically, it's just thousands of tiny adjustments happening invisibly across the city.
Yes. It aggregates the little guys to act like a giant. And this leads directly to the concept of vehicle-to-grid, or V2G, which is explicitly called out in these policy documents.
This is the idea that my car isn't just a car anymore. It's a battery on wheels that the grid can borrow power from.
Correct. The national policy envisions millions of EVs plugged in while people are at work or sleeping at night. The grid, managed by the AI, can pull power out of those car batteries if it needs to stabilize the frequency or meet a peak demand. It turns the entire national transportation fleet into a massive distributed energy storage system.
That's wild. I mean, it implies a level of connectivity and central control that is really hard for us to wrap our heads around here. It essentially dissolves the boundary between my private property, my car, and the public utility.
It creates a symbiotic relationship, or at least that's the goal. But from a pure engineering standpoint, it is brilliant. It helps solve the massive energy storage problem without needing to build trillions of dollars of new stationary grid-scale batteries. You just use the millions of batteries that people have already bought for their cars.
You use the assets you already have on the road. The report also mentions something called embodied AI in the context of these desert bases. I assume that means robotic.
Yes. This is the practical, physical maintenance side of the equation. We were talking about solar bases in the Gobi Desert or massive wind farms in the Taiwan Strait. These are incredibly hostile environments. You have sandstorms that can bury panels, extreme heat, or in the case of offshore wind, violent seas and corrosive salt spray.
Not a great place to send a human maintenance crew.
You can't. It's too dangerous and way too expensive.
Yeah.
So you send in the droids. They're deploying fleets of autonomous drones and increasingly humanoid robots for automated maintenance.
So what do?
The drones fly over the solar fields using thermal imaging to spot faulty panels. Robots that look like giant Roombas sweep sand off the panels to maintain efficiency. You have humanoid robots that can actually climb a 300-foot wind turbine to inspect the blades for microcracks using computer vision. The machine is becoming self-diagnosing and self-maintaining.
So Chenwei is sitting in a climate-controlled room, and out in the desert, an army of robots are keeping the lights on while the AI is balancing the load from millions of cars. It is a very sci-fi vision. But I have to play the skeptic here again. We always hear about these grand plans, but usually the economics don't work. Green tech has historically been expensive. The whole green premium idea. Is this actually affordable, or is it a massive money pit propped up by state subsidies?
That is the outdated heuristic. And this is where the story gets truly fundamentally interesting. The economics have completely inverted over the last 5 years.
How so?
According to the data we're looking at, particularly some analysis around Scott Galloway's recent work, the cost of solar power generation in China has absolutely plummeted. We are seeing utility-scale projects generating electricity at roughly 2 US cents per kilowatt hour.
2 cents. Okay, let's calibrate that for everyone listening. What does electricity usually cost in, say, the US or Europe?
In the US, industrial electricity is often 7 or 8 cents per kilowatt hour. In parts of Europe, especially recently, it can be double or triple that. 2 cents is, for all practical purposes, free energy compared to historical industrial standards. It is cheaper than digging coal out of the ground and burning it.
So the green premium is gone. It's now a green discount.
It's a massive green discount. And this new reality of abundant, almost free, clean electricity is fundamentally altering the global AI race. Think about the US strategy right now. We call it the Stargate model. That's the reported $500 billion project to build massive supercomputers with OpenAI and Microsoft. It is very capital expenditure, or CapEx, heavy.
It's about the hardware.
It's all about having the absolute best, most expensive chips, the NVIDIA H100s, the Blackwells. It is a hardware supremacy race. The logic is we have the best chips, therefore we win.
But China is cut off from those top-tier chips by sanctions.
So they cannot win a hardware supremacy race head-to-head. Instead, they are pivoting to what we're calling an electrostate strategy. They are using that 2-cent power to run massive amounts of compute for a tiny fraction of the operating cost. And because they're hardware constrained, they are forced to innovate like crazy on software efficiency.
Which brings us to those Alibaba statistics from the source material. I honestly had to read this twice because it didn't seem real.
It is staggering. Alibaba has developed new architectures for their energy-efficient large language models, their LLMs, that have effectively reduced the need for NVIDIA GPUs by up to 82%.
82%? That is not a marginal gain. That's not a 10% improvement. That is a complete paradigm shift. How is that technically possible? How do you replace a physical chip with just better code?
It comes down to the model architecture. Most of the current LLMs we use are what's called dense. That means for every query you type, for every token that's generated, the model activates a huge portion of its neural network. It's like turning on every light in your house just to find your keys. It's incredibly inefficient. Alibaba and others in China are mastering techniques like sparse activation or mixture of experts, MoE. Now imagine you asked a question about, say, biology. In a dense model, the whole brain lights up. In a sparse MoE model, the AI first routes your question to the small cluster of expert neurons that only know about biology. The rest of the brain stays asleep, consuming no power.
So you do the same amount of intellectual work, but with a fraction of the compute power.
The source notes that they could achieve a specific task with about 200 GPUs, where the standard dense model would have required around 1900. Now think about the geopolitical implication of that.
If the U.S. strategy is to starve China of chips, but China figures out how to be 5 or 10 times more efficient with the chips they do have.
The sanction is effectively neutralized. It loses its teeth. It becomes a minor inconvenience rather than an existential threat.
And it lowers the barrier to entry for everyone else in their economy.
And that connects to another key data point in the sources. As of late 2025, 9 out of the top 10 open source AI models in the world were Chinese.
That is such a fascinating reversal. We in the West usually think of the U.S. as the open democratic platform and China as the closed walled garden. But in AI, the big U.S. tech giants are locking their best models behind proprietary APIs and paywalls, while China is releasing theirs to the world.
In the context of the electrostate strategy, it makes perfect sense. They're providing the utility. They're basically saying, here is the cheap code and here is the cheap power to run it on. They are lowering the friction for their entire manufacturing base, their entire economy, to adopt AI at scale.
It's functionalist.
It's completely functionalist. It's not about having the best model to win a benchmark or for bragging rights. It's about having a system that works, that is cheap, and that can be deployed across the entire economy.
Which brings us right back to that consultant in D.C. He's celebrating a $0 value on a human life to save a bit of money for industry. Meanwhile, Chen Wei is using AI to integrate industry with the environment because, in her model, efficiency is preservation.
But that technology, that whole system, is only one leg of the stool. You can have the smartest grid in the world and the most efficient AI, but if the people don't trust the system, or if the local officials are corrupt and ignore the rules, it all falls apart.
Right. You need a social mechanism to enforce the engineering.
You need the social contract. And this is where we leave the high-tech desert of Ningxia and go to a coastal village near Ningbo to meet an elderly man named Mr. Gao.
This narrative is so important because it shows how this massive macro policy actually touches the ground, how it affects a real person.
It's the human layer of the machine.
So Mr. Gao is an elderly man, a former factory supervisor. He has lived through the entire arc of China's modernization, from poverty to industrial powerhouse. He vividly remembers the old way of the 90s and 2000s.
The growth at all costs era.
Exactly. And that wasn't just a slogan, it was the physics of his daily life. If you were a factory boss, environmental regulations were just suggestions, or more often hurdles to be bypassed with a bribe or a connection.
The pollute first, clean up later model, which often meant never cleaning up.
He talks about rivers running black with chemicals, the air being so thick you couldn't see across the street. But, wages were going up, people were getting jobs. But I saw a video of him from early 2026, and his whole tone, his whole reality is different. He's describing his participation in a community-led ecological civilization audit.
An audit. What does that mean in this context?
In his village, environmental protection isn't just a set of external rules anymore. It has become a core meritocratic standard that determines the careers of local leaders. He talks quite literally about how the measured clarity of the river water is used to grade the local officials on their performance.
That's fascinating, because it contrasts so sharply with what's happening in the West right now. In the U.S., for example, we're seeing regulatory rollback, fragmentation, states constantly suing the EPA. There's a deep institutional distrust. Mr. Gao seems to be describing a sense of renewed institutional trust.
He is, and it's because the rules are clear, and more importantly, they are absolute and consistently enforced. He used a phrase that really stuck with me. He called this whole framework social glue.
Social glue. That's a strange way to talk about environmental policy. Usually we think of green laws as restrictive, as something that stops you from doing things. How does it act as glue?
I had this same question. And to understand that, we have to look at the why behind all this. We have an academic paper here, The Search for Sustainable Legitimacy by Alex Wang. It argues that the state isn't doing this just out of some newfound benevolence for nature. They are doing it for something called performance legitimacy.
Performance legitimacy, meaning I don't need your vote to stay in power as long as I can prove I can deliver the goods.
That's the core of it. For 30 years, the social contract in China was simple. The party delivers double-digit GDP growth, and in exchange, the people accept its rule. But you can't have double-digit growth forever. And the side effects, the cancer villages, the smog that would shut down entire cities, the poisoned water, were becoming a direct threat to the regime's survival. People were getting angry.
The old deal was broken, the performance was starting to lag.
Exactly. So they needed a new deal, a new metric for success. And this is where the cadre evaluation system comes in.
Think of this as the human resources department for the entire government apparatus. Every mayor, every governor, every local bureaucrat has a scorecard. And for decades, that scorecard was like 90% GDP growth.
If the economy grew, you got promoted. End of story.
End of story. If the river turned purple in the process, nobody really cared. But now they have inserted hard targets for environmental performance directly into that scorecard. Things like sulfur dioxide reduction, energy intensity, water quality.
And when they say hard targets, are we talking about please do your best?
No. We are talking about do it or your career is finished. The sources we've looked at compare the strictness of these mandates to the old one-child policy mandates. If a local official misses these environmental targets, it does not matter if they doubled the local economy. They are vetoed.
Vetoed.
One strike, you're out. No promotion. Their career is effectively over.
Wow. That is an incredibly powerful mechanism. It effectively weaponizes the bureaucracy against pollution. It aligns the official's selfish desire for promotion with Mr. Gao's desire to see a clean river.
And they gave the central regulators a nuclear option for enforcement. It's a policy called Qisiampi.
Okay, Qisiampi, that sounds very bureaucratic. How does it work in practice?
It translates to regional approval restrictions, and its application is brutal. If a specific region, a city, a province, fails to meet its pollution targets, the Central Environmental Ministry in Beijing steps in and blocks all new industrial project approvals for that entire region.
Wait, you mean all of them? So if I'm a clean tech startup trying to build a new solar panel factory there, I can't get my permit because the old steel mill down the road polluted too much.
That is exactly what it means. It is a form of collective punishment. And it is absolutely genius in its political design. It forces the local mayor and the entire local business community to police each other. The clean tech guy now has a direct financial incentive to go to the mayor and say, you need to shut down that dirty steel mill because he is blocking my permit and my growth.
It breaks that old cozy alliance between local government and dirty industry.
It shatters it. And that explains why Mr. Gao is literally seeing the river clear up before his eyes. It's not because the factory owner suddenly found a conscience. It's because the system made it politically and economically suicidal to continue polluting.
Which leads to these images we see of the forced shutdown of backward industrial capacity. Small, inefficient thermal plants being dynamited or dismantled by work crews.
It is the physical manifestation of a policy shift from high-speed development to what they call high-quality development.
And it also addresses that inequality issue, right? Because historically, it's the rural areas, the places where people like Mr. Gao live, who get all the pollution dumped on them from the cities.
Yes. The environmental degradation was driving a huge wedge between the rural populations and the urban centers. By visibly cleaning up the countryside, the state is trying to heal that social fracture. It is, at its core, about social stability. If 2 million people a year are dying prematurely from air pollution, which was the historical trajectory, that is a recipe for massive social unrest.
So ecological civilization isn't just a nice-sounding slogan. It is a core survival strategy for the regime itself. The new performance legitimacy is based on this promise. We will keep you safe from the ecological collapse, and in exchange, you trust the system.
Which is such a stark contrast to the consultant in D.C., right? In his world, the system is actively removing the value of safety, that $0 value on a human life, to remove friction for industry. In Mr. Gao's reality, that safety is the product that legitimizes the entire state.
It's a complete inversion of values. And this inversion, this entire system, it doesn't just stop at China's borders. If you build this Electrostate machine, this incredible mix of AI grid optimization, hyper-efficient manufacturing, and strict social enforcement, you're going to generate a massive surplus of industrial capacity. And that surplus has to go somewhere.
And that takes us to Southeast Asia, to the coastline where the water is rising.
This brings us to our third narrative, the story of Eris. I want you to imagine a construction site in a flood-prone coastal region of Southeast Asia. It could be Indonesia, Vietnam, the Philippines. Eris is a local engineer, and he's overseeing the installation of a new type of climate-resilient modular seawall.
And this is where the Thwaites factor, from the beginning of our conversation, becomes the dominant variable in global politics.
It's no longer theoretical. The sea level is rising, and Eris's city is on the front line. But here's the crucial detail. Eris didn't get these seawalls from a Western aid package or a World Bank grant. He ordered them. They're part of a green supply chain that originates in China. He's looking at the shipping manifest, and these components were manufactured in those automated AI-powered factories we talked about, shipped on electric vessels, and that design was based on climate modeling.
So while the West is debating protectionism, tariffs, and trying to decouple, Eris is just trying not to drown.
That is the absolute crux of it. I see this as a pivot from the old order of diplomacy and ideology to a new order of practical resilience. Eris doesn't care about the political system of the country selling him the wall. He cares that the wall works, that it arrives on time, and that it's affordable.
He is looking for a clinical, data-driven solution to a physical, apocalyptic problem.
And this is the global projection of the Electrostate. We have data here from a Wilton Park report and a Shinhara interview with a World Economic Forum director that really quantifies the scale of this. In the year 2024 alone, China invested $818 billion in clean energy.
Let that number sink in. $818 billion. In a single year. That is almost incomprehensible.
And that level of investment creates a staggering amount of industrial capacity. We see it in the data on global lighthouse factories. These are the most advanced, sustainable factories in the world as designated by the WEF. 40% of them are now in China.
So they aren't just making cheap plastic toys anymore. The stereotype is dead.
Completely dead. They are making the hardware of survival, solar modules, grid-scale batteries, refining the critical minerals for the entire energy transition. But the geopolitical shift, the really big idea here, is that they are moving from trading commodities to exporting systems.
What's the key distinction there?
The 20th century energy order was built on selling barrels of oil. It was transactional. I sell you oil, you burn it, you come back next week for more. Saudi Arabia doesn't care what you do with it. But if I sell you an entire smart grid system, or a modular seawall system, I am embedding my technology, my standards, my engineers into your national infrastructure for decades.
You're setting the technical standards for their future. It's the Green Belt and Road.
It's exactly that. Eris is, whether he knows it or not, integrating his city's future into a Chinese technical standard. And this completely redefines the concept of de-risking that we hear so much about.
Right. In Washington and Brussels, de-risking means stop buying so much from China so we aren't dependent on them in a crisis.
But for Eris, standing on that coastline...
For Eris, de-risking means getting a seawall built before the next king tide, so my city doesn't disappear under the ocean. It's a much more immediate and existential risk.
The immediate physical threat always trumps the abstract geopolitical threat.
Always. The collapse of the Thwaites Glacier changes the global demand signal. When the climate crisis accelerates past a certain point, the global market stops caring as much about who has the freest market or who shares our values. The question becomes brutally simple. Who has the factories? Who has the supply chain that can deliver 1 million modular units next month?
And because China spent the last decade building this Electrostate, this massive frankly, overcapacitized green industrial machine, they are now the only ones who can credibly say yes to that question.
That is the hard reality of 2026. The West, and specifically that consultant we started with, is still stuck arguing about the cost. Is it too expensive to save these lives? Is it too expensive to build this wind farm this year? China has already paid the sunk costs. They built the factories. Now they're just looking for customers.
It's a new kind of pragmatism, isn't it? A survivalist pragmatism. And it forces a very difficult realization for us in the West. We spent decades worrying about China's rise as a military threat or an economic rival. But in 2026, with the climate physically breaking down, their rise starts to look different.
It looks like a lifeboat.
It looks like a lifeboat. And you might not like the captain or the rules on board, but if it's the only boat that floats in a storm,
You get on.
you get on. It's a lot to process. We've gone from the digital twin in the desert with Chen Wei, to the village audit with Mr. Gao, and now to the seawall with Eris.
And it is so important to see that it is all one cohesive, interlocking system. The AI optimization in the desert provides the cheap, clean power. The cheap power fuels the hyper-advanced factories. The cadre evaluation system ensures those factories are clean and that the social contract holds together. And the surplus industrial capacity from those factories builds the seawalls for the rest of the world.
It is a machine built for a very specific purpose, which is survival. And that stands in such stark, painful contrast to the paralysis we started this conversation with.
Think back to the DC consultant one last time. He represents a system that is fragmenting, a system where the EPA is fighting industry, where the grid operators are fighting the data centers, where the value of a human life is zeroed out on a spreadsheet just to make the math work for one more quarter. It is a system at war with itself.
Whereas the system Chen Wei and Mr. Gao are living in, and we should acknowledge, it is imperfect. It has its own rigidities and massive human costs, is, at least for this specific problem, pulling in one direction. It is a functionalist system. It has decided that survival is the #1 priority, and it is re-architecting the entire society to achieve that goal.
And that brings us to the ultimate friction of our time. It's not just a geopolitical rivalry between the US and China. It's a philosophical conflict between two operating systems, cost of progress versus value of survival.
That consultant was relieved that the value of life was 0 because it made his spreadsheet work. But Chen Wei's digital twin values the solar panel because it keeps the grid alive. Mr. Gao values the environmental audit because it keeps the river alive. Eris values the seawall because it keeps his city alive.
The spreadsheet versus survival, that really is the choice.
We've covered the AI plus energy strategy, the ecological civilization as a social contract, and the electrostate geopolitics. We've seen how they all weave together into what you called an architecture of survival. But as we close out this deep dive, I want to leave our listeners with a thought that really challenges the way we've been taught to view this competition.
It's not the old framework anymore.
We're so used to framing everything through the lens of the Cold War freedom versus tyranny, democracy versus autocracy. But the climate doesn't care about our political definitions. The ice simply melts.
And the water simply rises.
Exactly. So here's the final provocation for you to think about. We often talk about the future as a contest of values. But as the ice shelves fracture and the grids strain under the weight of AI, we might need to confront a colder, harder reality. The defining competition of the late 2020s won't be about who has the freest market,
but who's built a machine capable of withstanding the storm.
And if the price of survival is a system that values the collective algorithm over the individual choice, are we actually ready to pay it?
Or will we just keep adjusting the spreadsheet until the water is at our door?